The landing craft air cushion is a class of air cushion vehicle used as landing craft by the United States Navy's assault craft units and the Japan Maritime Self-Defense Force. They transport weapons systems, equipment, cargo and personnel of the assault elements of the Marine Air Ground Task Force both from ship to shore and across the beach. Design and development. Concept design of the present-day LCAC began in the early 1970s with the full-scale amphibious assault landing craft test vehicle. During the advanced development stage, 2 prototypes were built. JEF-A was designed and built by Aerojet General in California, with 4 rotating ducted propellers. JEF-B was designed and built by Bell Aerospace in New Orleans, Louisiana. JEF-B had 2 ducted rear propellers similar to the proposed SK-10 which was derived from the previous Bell SK-5/Senior N-5 hovercraft tested in Vietnam. These 2 craft confirmed the technical feasibility and operational capability that ultimately led to the production of LCAC. JEF-B was selected as the design basis for today's unregistered trademark SLCAC. The first 33 were included in the FY82-86 defense budgets, 15 in FY89, 12 each in FY90, FY91 and FY92, while 7 were included in FY93. The first LCAC was delivered to the Navy in 1984 and initial operational capability was achieved in 1986. Approval for full production was granted in 1987. After an initial 15-craft competitive production contract was awarded to each of 2 companies, Textron Marine and Land Systems of New Orleans, Louisiana, and Avondale Gulfport Marine, TMLS was selected to build the remaining craft. A total of 91 LCAC have now been built. The final craft, LCAC-91, was delivered to the U.S. Navy in 2001. On June 29, 1987, LCAC was granted approval for full production. 48 air cushion landing craft were authorized and appropriated through FY89. Lockheed Shipbuilding Company was competitively selected as a second source. The FY 1990 budget request included $219.3 million for 9 craft. The FY 1991 request included full funding for 12 LCACs and advance procurement in support of the FY 1992 program. The remaining 24 were funded in FY 92. The LCAC first deployed in 1987 aboard USS Germantown. LCACs are transported in and operate from all the U.S. Navy's amphibious well-deck ships including LHA, LHD, LSD and LPD. Ships capable of carrying the LCAC include the Wasp, Tarawa, Anchorage, Austin, Whidbey Island, Harper's Ferry, and San Antonio classes. All of the planned 91 craft have been delivered to the Navy. Of these 91 LCACs, 7 of these have been disassembled for FGE, 10 are in deep reduced operation status, 2 are held for R&D, and 36 are in use on each coast at Little Creek, Virginia and Camp Pendleton, California. 8 minesweeping kits were acquired in 1994 to 1995. The craft operates with a crew of 5. In addition to beach landing, LCAC provides personnel transport, evacuation support, lane breaching, mine countermeasure operations, and marine and special warfare equipment delivery. The 4 main engines are all used for lift and all used for main propulsion. The craft can continue to operate, at reduced capability, with 2 engines inoperable. They are interchangeable for redundancy. A transport model can seat 180 fully equipped troops. Cargo capacity is 1,809 square feet. The LCAC is capable of carrying a 60-ton payload, including 1 M1 Abrams tank, at speeds over 40 knots. Fuel capacity is 5,000 gallons. The LCAC uses an average of 1,000 gallons per hour. Maneuvering considerations include requiring 500 yards or more to stop and 2,000 yards or more turning radius. The bow ramp is 28.8 feet wide while the stern ramp is 15 feet wide. Noise and dust levels are high with this craft. If disabled, the craft is difficult to tow. In recent years, spray suppression has been added to the craft's skirt to reduce interference with driver's vision. The LCAC is a dramatic innovation in modern amphibious warfare technology. It provides the capability to launch amphibious assaults from points over the horizon from up to 50 nautical miles offshore, thereby decreasing risk to ships and personnel and generating greater uncertainty in the enemy's mind as to the location and timing of an assault, thereby maximizing its prospects of success. The LCAC propulsion system makes it less susceptible to mines than other assault craft or vehicles. Due to its tremendous over-the-beach capability, the LCAC can access more than 80% of the world's coastlines. Previously, landing craft had a top speed of approximately 8 knots and could cross only 17% of the world's beach area. Assaults were made from 1 to 2 miles offshore. Its high speed complements a joint assault with helicopters, so personnel and equipment can be unloaded beyond the beach in secure landing areas. For 20 years, helicopters have provided the partial capability to launch OTH amphibious assaults. Now, with LCAC, landing craft complement helos in speed, tactical surprise and without exposing ships to enemy fire. The similarities between a Navy LCAC and an airplane are substantial. The craft master sits in a cockpit, or command module with a headset radio on. He talks to air traffic control, which for LCACs is well-deck control located near a ship's stern-gate. The ride feels like a plane in high turbulence. The craft master steers with a yoke, his feet are on rudder control seguro, and he flies a lot like a hockey puck on an air hockey table. The LCAC is similar to a helicopter in that it has 6 dimensions of motion. Operating the LCAC demands unique perceptual and psychomotor skills. In addition, with a machine as expensive and inherently dangerous as the LCAC, sound judgment and decision-making also play an important role. Concerns over escalating training cost, projections for an increased number of LCAC vehicles and crew, and a high attrition rate in training highlighted the importance of developing a more accurate means of selecting candidates. Attrition of operators and engineers has dropped from an initial high of 40% in 1988 to approximately 10 to 15% today. In fiscal year 2000, the Navy started an LCAC service life extension program to add 10 years of design life to each craft. The SLEP will be applied to 72 LCACs, extending their service life from 20 to 30 years, delaying the need to replace these versatile craft. Without a SLEP, the first LCAC would face retirement in 2004, based on a 20-year lifespan. Naval Sea Systems Command has been working with Textron Marine and Land Systems since April 1996 on LCAC SLEP research and development. The actual SLEP modifications are planned to be conducted in 2 phases. Phase I. Over a period of several years, electronic system recapitalization will take place at each assault craft unit, where the craft are physically located. This will involve replacing current electronics components, which are increasingly becoming obsolete and unsupportable, with an open electronics architecture using easily upgraded, commercial off-the-shelf components. The new electronic suite will be more reliable and less costly to operate and maintain. Phase II. Buoyancy box replacement will be conducted at the Textron Marine and Land Systems facility in New Orleans, Louisiana, where Textron will use design changes, coatings, and changes in materials to increase the LCAC's resistance to corrosion. Phase II will also include the electronics upgrade of Phase I, until the entire active fleet is outfitted with a new configuration. The new buoyancy box will incorporate improvements to damage stability and trim control of the LCACs. NAVSEA transitioned from the research and development effort to the SLEP in 1999. Concurrently, NAVSEA also considered additional SLEP options, including an enhanced engine to provide improved operation in excessively hot environments and an advanced skirt that is more reliable and cost-effective. The Navy continued the LCAC service life extension program in fiscal year 2001. This program combines major structural improvements with command, control, communications, computer and navigation upgrades and adds 10 years to the service life, extending it to 30 years. In FY 2001, it was funded at $19.9 million and extended the service life of one craft. The SLEP is planned for a total of 72 craft. The near-term focus will be on the C4N, Command, Control, Communications, Computers, and Navigation program, to replace the craft's obsolete equipment. This will focus on replacement of LN-66 radars with modern, high-power P-80 radar systems. Additionally, the SLEP will include an open architecture concept, relying on modern commercial off-the-shelf equipment, which will allow much easier incorporation of later technology changes, such as the Precision Navigation System and Communications Systems are three-quarters fully interoperable within service, and near-term future joint systems are three-quarters now planned. The C4N program is to complete by 2010. Through 2016, the Navy will look to incorporate other important service life enhancements, engine upgrades that will provide additional power and lift, particularly in hot environments, reduced fuel consumption, reduced maintenance needs, and reduced lift footprint. Replacement of the buoyancy box to solve corrosion problems, incorporate hull improvements, and reset the fatigue limit clock. Incorporation of a new skirt that will reduce drag, increase performance envelope over water and land, and reduce maintenance requirements. As of September 2012, there are 80 LCACs in the U.S. Navy inventory, and 39 of these LCACs have undergone the SLEP conversion, 7 more SLEP conversions are in progress and 4 are awaiting induction. The FY 2013 budget authorizes 4 SLEP conversions per year through to FY 2018. The last of the 72 SLEP conversions will be delivered to the Navy in fiscal year 2020. A number of LCACs are currently under development and testing at the Naval Support Activity Panama City in Panama City, Florida. As the first SLEP LCAC reaches its 30 years of design service in 2015, they will gradually be retired. In 2019, at which point the inventory of LCACs will have fallen to 50, the USN begin receiving the new ship-to-shore connector, the LCAC 100. The USN inventory of LCACs will continue to fall, as the SLEP LCACs are retired, until 2023, when the inventory will reach a low of 40 SLEP LCACs and SSC LCAC 100s. The inventory will remain at 40 until 2026, when the production of SSC LCAC 100s will begin to outnumber the retirement of SLEP LCACs. Current projections foresee the inventory rising to 60 SSC LCAC 100s in 2031 and 72 SSC LCAC 100s on 2034. Ship-to-shore connector equals. The SSC LCAC 100 will have an increased payload of 73 short tons. It will have pilot-co-pilot dual controls with a smaller crew and a new command, control, communications, computers and navigation suite. It will also have engines offering 20% more power with new full authority digital engine control, a simpler and more efficient drivetrain with one gearbox per side, and a new heating, ventilation and air conditioning system. It will be constructed out of aluminum 5083 with better corrosion resistance and an immersion-grade wet deck coating system, and its gear shaft and fan blades will be constructed with extensive composites. It will be able to operate with a 74 short-ton load at a sustained speed of 35 knots in NATO Sea State 3 to 4. Japanese operations. 6 LCAC are in use by the Japan Maritime Self-Defense Force. Approval for the sale was given by the United States government on April 8, 1994. The craft were built by Textron Marine and Land Systems in New Orleans, Louisiana. Purchase of the first craft was included in the FY 93 budget, second in FY 95, third in FY 99 and fifth and sixth in FY 00. Operators: Japan, Japan Maritime Self-Defense Force, United States Navy, Assault Craft Unit 4, Assault Craft Unit 5. Specifications: Builder, Textron Marine and Land Systems, Avondale Gulfport Marine. Date deployed, 1982, propulsion, Legacy 4 Lycoming Allied Signal TF40B gas turbines. 16,000 horsepower sustained. 2 shrouded reversible pitch air screws. 4 double-entry fans, centrifugal or mixed flow, service life extension program, 4 Verica Power Systems ETF40B gas turbines with full authority digital engine control. Length, 87 feet 11 inches, beam, 47 feet, displacement, 87.2 tons light. 170 euro 182 tons full load, speed, 40 plus knots with full load, 70 plus knots maximum speed, range, 200 mi at 40 carats with payload, 300 mi at 35 carats with payload, crew, 5, load, 60 tons per 75 ton overload, military lift, 24 troops or 1 MBT, armament, 2 12.7 mm machine guns. Gun mounts can support the M2 HB.50 Coloris machine gun, Mk19 Mod 340 mm grenade launcher, or the M60 machine gun. Tests conducted with GAU 1330 mm Gatling gun. Radar, navigation Marconi Lane 66. I-band, source, LCAC U.S. Navy fact file. See also, air-cushioned landing craft, engine Dadar copyright Bachmont Amphibie Lebed class LCAC, Zarplia class LCAC, 3 in service with ROKN, Zubia class LCAC. References. General, Saunders, Stephen. Jane's Fighting Ships, 2003-2004. ISBN 0-7106-2546-4. External links, LCAC U.S. Navy Fact File, Textron Marine and Land Systems LCAC page, LCAC specifications on globalsecurity.org, LCAC page on FAS.org,